Hello everyone, welcome back. In this lesson, we will learn how to pre-process Landsat 8 Collection 2 Level 2 imagery before performing any remote sensing analysis. This is one of the most important steps because raw satellite imagery contains clouds, cloud shadows, and atmospheric effects that can significantly reduce the accuracy of our results. So let's begin. So we'll begin by creating a function called mask layer that named as a mask LH9SR. Inside this function, we have used a QA pixel band. The first thing we do is to access the QA pixel band. The QA pixel band is actually that stores information about the clouds, cloud shadows, snow, cirrus, and other unwanted pixels. So that's why we are using it. So we use the following line here is the binary represent the first 5 quality bits using bitwise AND operation. We identify pixels affected by the clouds and cloud shadows. So that's why we're going to use this. And only that pixels that are equal to 0 considered as a clean observations. So we are choosing QA pixel and then we are saying that represent the first 5 quality bits, and this will identify the affected pixels that are affected by the clouds and cloud shadows. And then we are saying it that the pixels that are equals to 0 show me that. So that's how it's gonna work. Okay, in the next step we remove those saturated pixels like the QA rad set band. Okay, in the next line, we remove the saturated pixels. The QA rad set band identifies pixels where the sensor became saturated due to excessive brightness. So we're going to use this to remove the pixels that became saturated due to excessive brightness. So removing these pixels improves the quality of our analysis and somehow. Okay, in the next step, we scale the optical bands like Landsat Collection to store reflectance values as integers rather than decimal reflectance. So to convert them into an actual reflectance values, we use this multiplication and addition function. So this converts the digital numbers into surface reflectance values between approximately 0 to 1. It's from 0 and it's maybe 1. The thermal band ST. Here is another operation or another variable in Google Earth Engine. So that comes the thermal bands. The thermal band ST band 10 is stored as a scale Kelvin value. So we convert it using multiply it with this value and adding with this value. So what it's gonna do is this line. This produces temperature in Kelvin. Since most studies require Celsius, so we subtracted it with minus 273.15. So finally, we replace the original bands with the scale bands and apply both masks. Now, every image entering our analysis has a cloud removed. If they have any cloud shadows, they'll removed, and if they are saturated pixels, they're gonna remove. If they are optical bands converted to reflectance, and then thermal bands converted into degree Celsius. So this pre-process step is essential before calculating any indice you're gonna do or any other environmental indice. So this is the most important step to do for the Landsat 8 imagery or any Landsat series. Okay, so now we have created our pre-processing function. And let's use it to prepare Landsat imagery for analysis. And we begin by importing the Landsat Collection 2 level 2 dataset. So here is the dataset that we're going to use. And image collection is simply a collection of satellite images acquired over the time. So next we limit the collection to our study area. We apply filter bounds to restrict it to our study area, that is region of interest that I have defined over there. This ensures only load images intersecting our region of interest. So after that, we specify the analysis period, and that period is only images captured within time range will be included. And next comes the most important pre-processing step. And what is it? The map function automatically applies our cloud masking and scaling function. Like this cloud masking and scaling function to every single Landsat image in the collection. Like it's instead of processing images one by one, Earth Engine perform the operations across the entire dataset. So we can inspect the process collecting uh, using only we can inspect the processed collection using this. So the console display the number of images, acquisition dates, metadata, available bands, and everything. However, we usually don't want to analyze dozens of images individually. Instead, we create one representative images. So for that, we create a median function over here. So the median composite calculate the median pixel values across all images. So this method effectively reduce any remaining clouds, contaminations, or produce a cleaner, more stable image. So after all of that, the result is a single cloud-free composite representing the selected time period. Okay, this composite becomes the foundation of all the subsequent analysis, including vegetation, water, any other analysis you're gonna do. Okay, so now we are going to calculate land surface temperature using Google Earth Engine and Landsat 8 collection to level 2 imagery. So Landsat temperature represent the temperature of the Earth's surface rather than the air above it. So it is an important environmental parameter used to study urban heat islands, climate change, droughts, and agriculture, and many more. So I will explain every line of the code, how you can do land surface temperature using Google Earth Engine, how to visualize the temperature map, and finally export it as a geotiff. So let's get started. Okay, so the first step is selecting the ST band 10, and this is a thermal infrared band provided in the Landsat 8 collection to level 2 product. Since we already applied the scaling factor and converted to temperature from Kelvin to degrees Celsius during pre-processing, so this band now contains land surface temperature values in degrees Celsius. So by selecting this band, we are preparing the temperature data for visualization and export. By selecting this band, we are preparing the temperature data for visualization and export. Now we are clipping our LST to our region of interest. To focus only on our area of interest, we use dot clip function. So this will remove all the pixels outside the region of interest, producing a cleaner output and reducing unnecessary data. And next we are creating a visualization object so that it only affects the appearance of the image and does not modify original temperature values. So this will make sure how our image will look like on the map. So our minimum value is 20 and maximum is 30. Pixel with the temperature below 30 degrees Celsius will be displayed using the first color in the palette. And the maximum value, this will specify the maximum display values. Pixel with the temperature above then the maximum values will use the last color in the color palette. So minimum and maximum values should always be adjusted according to the climate and study area that is being to analyze. So then we have palette, like colors. The color gradually change from blue to green, yellow, orange, and finally red. So generally blue colors represent the cooler surfaces and the red surface indicate higher LST. And then we have this operation. So this line add the land surface temperature layer into the Google Earth Engine map. This is the map. So this operation will add this layer into the map. And the first parameter is the image we want to display. The second parameter contain the visualization parameters, and the third is by we are renaming it. And now we are exporting our land surface temperature raster to Google Drive. So this allows us to use the temperature map later in GIS software for additional analysis, mapping, and report preparation. So this specifies which image we are exporting this image. So we are using the LST clip here, and then we have a description like what name you want to see on the drive. So I want it as LST 2020. Then we have a scale. The scale would be same as that of the dataset we have used. We are using Landsat 8 collection to level 2, and the resolution of it is 30. So scale we are setting here is also 30. Then we have region of interest, like for which region we are selecting our uh, LST. Then we have a file format, and finally we are defining max pixels. You can also increase max pixels to handle the larger exports. So here is the final results of LST. So higher temperature, the reddish areas are the higher temperature. So these are commonly observed over urban areas, roads, industrial zones, and the areas that are paved. And then we have lower temperature where the vegetation may be present. By examining the spatial distribution of surface temperature, we can identify thermal hotspots and better understand how land cover influence the local climate. So we have a lot of applications of LST, like over the period of time, how LST is changing and how it's affecting other land covers. So LST is often combined with NDVI, NDBI, NDWI, and BSI to study the relationship between vegetation, built-up areas, water bodies, and bare soil and surface temperature. So here's how we can calculate land surface temperature in Google Earth Engine using Landsat 8. In this tutorial, we selected thermal bands, clip it to our study area, create visualization parameter, displayed the temperature map, and export it to the final raster as a geotiff for further analysis. I hope this tutorial helped you understand not only how to work with the land surface temperature in Google Earth Engine, but also why each step is in the workflow is so important. If you found this video helpful, please like, subscribe, and turn on the notification bell so you don't miss future tutorials on Google Earth Engine, remote sensing, GIS hydrology, and other observations. So thank you for watching, and I'll see you in the next tutorial. Bye.